Section 8.3, graphing general rational functions. So we've already graphed some simple rational functions, and so you should have an idea of how to find a vertical asymptote and what that means, and have a little bit of an idea of how to find some simple horizontal asymptotes. And so we're just going to expand on that a little bit and find a couple other key portions of a graph. And so, first of all, a general rational function, again, is basically a function that has x's in the numerator and denominator. And so one thing that helps graph some of these is to figure out where they cross the x-axis. Let's find the x-intercept. So let's think about what that means. Having an x-intercept means where it crosses the x-axis. And if you have a fraction, that basically means that the y-coordinate needs to be 0. So if you have a fraction, what's the only way that a fraction can equal 0? Well, if you think about that, the only way that that can happen is if our numerator equals 0. So that's how we're going to find our x-intercept. Set the numerator equal to 0 and solve for x. The next thing we need to do is find our vertical asymptotes. And what that means is, where is the function not defined? Where can a y not exist? And we can't divide by 0. So now we're going to let the denominator equal to 0, and that will be our vertical asymptotes. Then we have our horizontal asymptotes, and one of three things can occur. Either the degree of the numerator is less than the degree of the denominator. So let's take a look at what that might look like. If we think about what a horizontal asymptote is, it's what the graph or what the function is doing is x gets really, really big. So think about x being huge, approaching infinity, or bazillion. And so those things that we're adding on at the end after we've raised our variable to a power don't really matter once x gets really, really large. So we're just going to look at 3x squared over x cubed. And if we were to simplify that, we would end up with 3 over x. And again, if we think about what happens as x gets huge, if I have a bazillion dollars and I decide to give you just 3 of it, I'm basically giving you nothing. And so my horizontal asymptote would be 0, y equals 0. The other thing that can happen is if the degree of the numerator is equal to the degree of the denominator. And this is what we were basically dealing with in section 8.2 on our simple rational functions, except all of those were linear functions on the numerator and denominator. Again, as x were to get huge, it wouldn't matter that we're adding 10 and subtracting a 5x. We're just going to look at the highest powered term on the numerator and the highest powered term on the denominator. And if we simplify that, our x squareds would cancel out, and 3/6 simplifies to 1/2. So my horizontal asymptote would be y equals 1/2. And the third thing that could happen is if the degree of the numerator is greater than the degree of the denominator. And so again, let's take a look at what might happen. It doesn't really matter. Once again, as x gets huge, what we're adding or subtracting on the end, we're going to look at 3x squared over 2x. And again, if we were to simplify that, we would get 3x over 2. And if we think if x gets really, really huge, well, that number's really approaching infinity, and there's no horizontal asymptote. And so that would be the only case that there would be no horizontal asymptotes. So now let's take a look at a couple examples. In this first example, we're going to find our vertical asymptote. So we're going to set our denominator equal to 0. And if we solve that or factor that, we can get x equals -1 and x equals +1. Remember, these are vertical lines, so let's go ahead and graph those vertical asymptotes. And next, we're going to look at our horizontal asymptotes. So we're going to look at that ratio of our numerator, highest power in our numerator, to our highest power in denominator, so x over x squared. And if we were to simplify this, we would get 1 over x. And again, we're thinking, what's the graph going to do as x gets really, really huge? And this number is going to get closer and closer to 0. So our horizontal asymptote is going to be y equals 0, and we can graph that. We can also find our x-intercept by setting our numerator equal to 0, and we get x equals 0, so we could plot that point as well. So now we're going to make a t-chart, and when we're graphing these, we need to figure out what the graph is doing in those 3 sections. Our vertical asymptotes have divided our graph into 3 sections. And so we're going to divide our t-chart kind of into 3 sections. And our asymptotes are going to be those dividing points. And I'd like you to pick at least 3 points in each part of the graph. So 3 points to the left, -4, -3, -2. And in this case, we're going to have to pick fractions in order to be able to pick 3 points between. So negative half, 0, and half. And then 3 points to the right, 2, 3, and 4. And we're just going to take those points and we're going to plug them into our function. And the easiest way to do that is in your graphing calculator. If you plug this into the y equals, you just need to be careful that you're putting parentheses around the numerator when necessary, and especially in this case around the denominator. And you should try to do that and make sure that you get these values when you plug in negative 4, negative 3, negative 2. You can either look at these on the trace of the graph, or you could go to the table function in the calculator and it should show you a table. And there will be an error and nothing will appear at negative 1 because that's an asymptote and it's undefined at that point. Plugging in negative a half and 0 and a positive a half. Again, it's undefined at 1. And then at 2, 3, and 4. And then we're going to use the asymptotes and use the idea of whether these points are above or below the horizontal asymptote and graph all 3 sections of the graph. So that would be the left section, the middle section, and the right section. Alright, let's take a look at this next example. Again, let's set the numerator equal to 0. So if we set x squared equal to 0, we're going to get x equals 0, so we can plot that point. To find our vertical asymptote, that's where our graph is undefined, so we're going to take the x squared minus 4 and set that equal to 0. We can factor it or solve that and get x equals negative 2 and positive 2. So those are 2 vertical lines that we can graph. And then next, our horizontal asymptote. Again, we're looking at the ratio of the highest powered term in the numerator and the denominator. And if we simplify that, we get 1. So our horizontal asymptote is y equals 1. And we can graph that horizontal line. Again, we're going to use our vertical asymptotes as our guides for our t-chart, picking 3 values to the left. Then we have our asymptote. In this case, our 3 values to the middle can be whole numbers. And then our right asymptote, and then 3 points to the right. Again, plugging this into your graphing calculator, and again I would try this to make sure you get the right values. And so then again, negative 5 is going to be above that horizontal asymptote, so then we can kind of use our idea of our asymptotes as our guides, and that's our left portion. Our middle portion, the negative 1 is negative 0.3, and then positive 1 is negative 0.3, so that's going to give us more of an upside down U. And then on the right side, we're going up again. And that's what our second graph will look like. I'd like to get you started on this third graph, and then I'd like you to finish it. So you can find the x-intercepts, but then our vertical asymptote, you set the denominator equal to 0. And so we need to figure out what x is, and then graph the asymptote. And then our horizontal asymptotes, again, we're going to look at the ratio of our highest powered term on the numerator and denominator. We're going to get x over 1, so as x gets huge, we're not going to have a horizontal asymptote. Remember, this is when we have no horizontal asymptote. So you're going to need to make our t-chart, and then graph the points. And this one's going to look a little bit different than the other two. So be a little bit careful when you're picking your points and make sure you're graphing accurately. Then I'd like you to remember if you remember how to factor. So I would like you, I don't remember if your note packet has these in them. If it doesn't, I'd like you to write them down and try to factor these. And we'll factor these at the beginning of class. And then here's 2 more. This last one, x cubed minus 64, you might have to look this one up. And if you look it up in the index of your book, you should be able to look under the difference of perfect cubes. This one's a little bit different. I'd like you to make sure that you have any questions, you come to class with them. I do have an extra credit for this last graphing one that you did is going to have what's called a slant or oblique asymptote. So I have an extra credit worksheet that kind of explores that for you. So if you'd like to get that, you can. If you have any other questions, then I guess that would mean you might be ready for a pop quiz. Or you might want to write down those factoring problems and try those and have those ready to go when you get to class. And we'll see you in class tomorrow.